Hello and welcome to another Clojure study group. My name is John Stevenson and thank you for joining me. We've got quite a few people watching live, so that's great to see. And if you've got any questions, please put them into the text chat and I will try and answer them as we go along. So today we're going to look at regular expressions. Ooh, the mystic world of regular expressions. If you've ever done any Perl programming, then you're probably quite comfortable with regular expressions. If you're not, then it can be a little strange to get used to them, but we can see what, give you some examples, give you a nice intro into regular expression, and try and come up with some, try and come up with some simple uses for regular expressions as well. So I haven't switched over to OBS, so let's share my screen and get the Frankie effect. We'll be in OBS next week. Yeah, so next week I'll be moving over to the Practicalli YouTube channel. We've got 2 subscribers already. So I'll put a video on the existing channel to point you to this channel, and it'll just mean that you can access just the Clojure related videos, and you don't have to look at all my cycling through London videos, and you can subscribe to specific content that way. But I'll put that, you'll see, you'll just be able to follow the link that I put in the meetup groups as well, and that will get you there. Let's go here. Oh, excuse me. So I started doing this regular expression because we've got Foreclosure 37, I think. Is that right? Yes, it is. There we go. So we've got this foreclosure problem number 37, and it basically tells you it's regular expressions. And so we'll talk about what those are, and basically what is the answer to this expression. And the answer equals ABC, but how do we actually get there? What does it actually all mean? The start of it is, yeah, so the outer part of it is just turning it into a string. So this is going to obviously going to generate some particular characters we want to from this string. We're going to pull out some characters using this regular expression. So we're going to create a new sequence of strings, of characters using this pattern from the string. Oh, excuse me. Sorry, I have a cough this morning. So let's switch over to the code. I think I got there. We got Spacemax. You don't have to use Spacemax for Clojure, but it is my favorite tool. Switch to a nicer backdrop. There we go. So this is a foreclosure problem, and so the easiest way to evolve it is to answer, really. You don't actually have to understand the code. The nice thing about Clojure initially is you can just run the expression and it gives you the result. You may still need to go off and actually figure out how it's getting the result, but you can kind of go and see what it's doing very quickly just by using the REPL. That's what we did here. Just evaluate it and it gives us an ABC. So that's obviously the answer that fits it. I'm just going to leave that on there for now. So what are regular expressions? Let's have a look at that. So one definition is when you're writing a regular expression, it's like asking the question, does a group of characters match a specific pattern? So you've got a pattern here, and we'll explain what this pattern means, but basically it means any uppercase character between A and Z. So this is a range. and the plus just means multiple ones. So if there's a character in this string that matches the pattern, then we're going to take it and we're going to initially going to create a sequence out of that. So let's just look at that specifically. Just evaluate that. So the reseek is creating a new sequence. So in this case, a list, and it's creating the list by applying the pattern of the regular expression to the string that we give here. And so it's saying, oh, A, that's capital, B, that's capital, C, that's capital. So it pulls those out into individual characters, and then we're just going to map. So then we're just mapping mapping a function. I want a function to join characters together, so that's short string, and the characters themselves. And if we evaluate this, then we get the, what did it do there? Oh, yes, sorry, oops, because it's a list. I didn't quote escape it. It's trying to call the string A as a function. There we go. There we go. Oh, it's not map, is it? Sorry, what am I doing? I'm map obsessed this morning. There we go. So map would just turn each of the individual elements to a string, which they already are. That's why I got the same result here. If you want to apply, or I guess we could use reduce as well. So we basically want to create a single string. There we go. And I think reduce will do the same thing as well. So there's much difference here. There's not much difference for this particular trivial example. I mean, there's some underlying differences between reduce and apply, but not in this case. It's not apparent. So this is what we're doing. So so for the answer, we're building a sequence by applying this pattern to this string and seeing what matches, and then we're taking the result of that and turning it into a single string as the answer. So that's the foreclosure part of it done, but it's an opportunity to go and actually look at regular expressions in a little bit more detail. So that's what we'll do for the rest of the session. Thank you for the welcoming messages in the chat. So regular expression. So we've seen that it's a group of characters matching a specific pattern. So in Clojure, the way we define a regular expression is using this hash and the double quotes. So you do hash, double quotes, and then there's some kind of pattern you would put in here. That would actually match, that we'd use for passing over the string to see what matches. So it's a fairly simple syntax, but there's more things we can do. As we can see, we can create sets and so on. So we'll look at all the different things we can do. Simplest one I thought of was cat. So we can kind of see if any of our strings match the pattern cat. We can see underneath that this is, if we weren't sure what this meant, we could actually give it to this type function, and it would tell us what kind of type it is. So if we weren't sure what the hash double quotes meant, we evaluate this, then we can actually go in and see, oh, okay, it's a regex pattern. So regular expressions, short term is regex. Although I find saying regular expressions easier than saying regex sometimes. And so we can see it's a specific pattern that we're defining. And you can see that this is actually from the Java util package. So this isn't specific to Clojure itself. We're actually using the underlying Java libraries and Java methods in this case, which Get Clojure does quite a lot on the JVM, obviously, and it can use that. So there's no point in rewriting parts of the functionality that Java gives us when we're on the JVM. And it is obviously it's going to be slightly different on the if you're running this inside the Clojure scripts REPL, then obviously you would have the equivalent of the regex in JavaScript. So and there are quite a few functions that will take a regular expression, so we'll look at some of those. And basically they're going to return the matching string. So if I did a regex with cat on the string, then let's see if we do like refind is one example that we use. We do a regular expression of cat, and if we have a string of like cat, is that going to match? Is it going to match? Because it's plural. That's interesting. Let's see what happens. It does, because it finds a pattern called cat, so it's returning cat in there. And we can obviously do things like let's see. We want to get a bit functional. Let's see. We can change the word to concat to concatenate. There we go. Is that not how you spell concatenate? I'm not sure. There we go. Yeah. Still, because cat's part of that word, it's returning sort of match. And if cat is not part of the word, oops, then let's see, there's no cat in there, so it's going to return nil. So we can use that as a kind of a falsy, so true false kind of test. If I'm pretty sure that's not spelled right. If I use this inside an if statement, I can kind of see whether we've got a correct result or not. So we'll look at that shortly as well. This is basically what it's doing. It's searching to see if there's a successful match, and if there is, then the regular expression will return that match, that string that matches. And as we've seen, if there's no match found, then nil's returned. So we can treat that. You can put that into an if test. And so on. What can we use regular expressions for? Well, if you're doing any validation, they're very, very useful. So if you're filling in like a web form, you want to check phone numbers, email addresses, passwords, etc., then you can use regular expressions to help you do that, because there's some structure, but then it's more about, with regular expressions you can define patterns rather than places. So if you want if you've got an email address, you could have John at Practicalli practical. Got my own email address there. And or you could have John that's not a real email address. I don't work for a megacorp at the moment. But there's, if you wanted to test to see whether this was an email address, we need to find one test we would look for is there an @ sign in the text, but it could be anywhere. It could be, there's no kind of fixed set of numbers or letters in before or after. So we could actually just iterate through and find it as well, but just using pattern matching, which is essentially what regular expressions gives us, it allows us a simple way to kind of say, oh yeah, there's an @ sign in it, so it's looking kind of legitimate as an email address. And the same thing with passwords and sizes. We could check to see if the password got any special characters in there. So some password schemes make you include like special characters like question mark and ampersand and so on. So you have to do those kind of things. If it wants to see one of those, so you can use regular expressions to help you understand if one or more of those is contained within inside the password. Yeah, and you can see if the phone number has got any words in it. You only want numbers in your phone number. That's one of the things you can test as well. And so that's quite a common way to use regular expressions. Also, like just searching for things in strings. And so we'll see an example of how we're searching for things in an online, so like a digital version of a book. Well, I'll do that as an example towards the end. There are some nice tools out there as well to help you kind of practice regular expression, although I think just doing them in the REPL is actually just as good in Clojure as well. But if you're using other languages, then they might be quite useful that way. So we're going to look at some Clojure functions. It's mainly going to be refind and reseek. Refind will just return the first match it finds, so we can just see if something's in there. So if it's a case of an email, like does it contain the @ sign? And if it does, that's great. Although you might want to actually check to see if it contains it more than once. So in that case, you do resequence and then maybe count the number of ampersands that are inside there. If there's 0, then it's wrong. If there's 1, then it's okay. If there's more than 1, then it's wrong as well. So, oh, that's an interesting idea. I might do that at the end. Let's see. Seek. Email. That's an interesting one. Okay, so I've got a few examples I'm going to cover here. Checking phone numbers, for example. Boom, boom. So here we got some phone numbers, and we want to check to see if the telephone number is the regional code. So like we're in this example where an international company taking orders for other businesses, and we want to check that the phone number is the same as the number that's on the address. So if the address is London, we want to check that the regional code for that telephone number is the same as the address, just as a quick sanity check. Because if we want to deliver something and we want somebody there, we want to be able to call somebody at that location. So it gives us a guide to see at least it's the right kind of area. So I've defined a bunch of names bound to these phone numbers just as a convenience. And I've got a number that's not for London as well. And so we could just do what we call literal match. So just actually using the specific pattern, like we did with cat. We can do a specific match of using the first 3 digits. So this is the first 3 digits 020 of the telephone number that represents, that's the London regional code. And so we can see whether I'm going to keep it up there. I'm going to see whether phone no gaps, so whether this one actually includes 020. Of course, the interesting thing is that yeah, it could be further inside the phone number. For this example, we're just kind of checking a very simple check, so it could be thrown up These could generate false positives, but at least it's a start on how we can use regular expressions to find if a number at least includes O2O. So we're going to do refine. So we're going to see if there's a match in there. And yes, there is. So that matches. And obviously the other London number is going to match as well. And but this one doesn't. So this is not London, so it doesn't have O2O in it. So that is false. And therefore it returns nil. And we can map. That's probably why I put map in earlier. I was doing this. So we can map this regular expression over all our numbers. And we can see whether they are London numbers or not. So these are all numbers. So we've got 1, 2, 3, 4, 5, 4. 1, 2, 3, 4, 4. We've got 4 numbers that are London numbers, and it returns our 4 strings. So if we did a count on this that equals 4, then that's our test. So we can do. Oh yeah. So I just basically put all the numbers in there, so it makes the code a little bit easier to follow. So if we did a count around this of and so we get 4, and so we could have a test that is so equals. Oops, where's my equals gone? Equals 4, and then the count of this. There we go. And that should equal true. Yay! There it goes. So yeah, so we can see how many numbers match with our code. So we can do some batch processing of the numbers, and if there are any issues, then we can kind of go back in and figure out which ones are actually causing the problems. And here I'm adding. Oh yeah, here I did the not London one to the numbers. So if I do all numbers, then it's going to give us a nil at the end, because that's the last number. And the not London number is the last one in the sequence, so that's going to return nil. So that's a very simple way of just using a specifically literal kind of regular expression pattern. So this is a literal pattern here. 0, 2, 0 is exactly what we're looking for, and we can find that very easily just doing refines or reseek, or just mapping refined over a whole bunch of numbers. We can also do things like if we didn't have refined, we can also use this to get the first part of the number there if it matches. If we wanted to just split apart our number, we can use Clojure.string.split. This is also using a regular expression as well, so they're really useful in lots of kind of aspects of dealing with strings. And here we're just using this particular pattern. So this is a particular regex pattern where we're doing the \s. That's kind of representing space. It's a bit hard to kind of do a. You can do it in the kind of literal way of just having a space in there, but it's very easy to kind of miss that if that's the only thing in your pattern. If space is the only thing in a pattern, that's quite obvious. But if it's you got a lot of text in there, it can be quite easy to miss the fact that you've got the space in there. So I think it's always quite nice to do an explicit space, so backslash s. And the plus again just means that there can be more than one space. So if we let's move that out of the way for a second. So if we look at split, let's see what that does. Let's just see if it works properly first. So that's splitting up the numbers, and it's putting them into their own strings inside a vector in this case. And if and that will work with even if there's kind of multiple spaces in there. That should still work. Oops. Do this. There we go. Do the same answer. However, if we take the plus away, then this might not work. I don't think it would work. Oh yeah. So actually, that's interesting. So it's putting in these extra quotation, extras like blanks in between the numbers, because that's what there is in between the spaces. There's a space, so it puts in some extra strings in there. So you'd have to, if you didn't have the plus, you'd have to format the output of this if you wanted a meaningful result in that respect. But you can see what if we do plus, then it's going to match all those strings, and it's going to give us the desired result that we want. There we go. So there's examples of using specific strings, and you could use subs. But if you're not using regular expressions, then you kind of have to know pretty clearly what your data is doing. In this case, if we're using subs, then we have to know where things are. So I mean, this is okay for very tabular kind of data where you know the start and end points of the cells of data. That's fine. But I'm really oh, excuse me. Hope that wasn't too loud. Sorry, yeah. So if we're using something like subs without a regular expression, then we have to be very specific about where things are. We have to know a lot more about the structure of the data as well. So it's a lot less flexible. So here we just we know specifically where the data is going to be. So for like the start of a number, we know we want the first three numbers from that. So this string is treated like an index. So we start at 0 and then 1 and 2, and we don't include the third one. This is a bit like range in this case. So the third, the end value is exclusive, so we go up to that, but not including the third index. So that's 0, 1, 2, and then we don't include the third one, so we get 0, 0 to 0. But if we have like badly formatted strings or like lots of spaces or something else in front of that, then this is going to very easily break our subs. So we actually only get part of it. So that's probably the last 0 rather than the first one. If we put some more spaces in there, it shouldn't return anything at all, really. There we go. Empty space. Cool. Any questions? Oh. I'm not quite sure what that question is. Will not count 1, 0, 3 count. I'll come back to that in a minute. Where was I? Users, I'm not quite sure what you're asking there in the chat. Let me just put that code into the REPL and see what it's doing. Yeah. So okay. So yeah, I mean, nil is counted as a value. So if we wanted to see if there was a value in there, if there was a nil value, would actually explicitly look to see if there was a nil value rather than just counting those as well. Yes. So in here, again, it's not an ideal, like it's not a rock solid test to show that there is two. It was just another way of kind of showing that you can put that regular expression into a test, not a kind of a test that's quite easy to break in this case, because ideally, if you wanted to see if there was a wrong number in there, then you would you kind of map over them to see if there was, rather than doing count, you would do a test to see if there was a nil value in there, or you could just you'd use something like filter to remove. So before you did count, you could put in a filter in here, which basically gets rid of you put a filter in there that puts some condition in that would actually get rid of the nils as well as a better test. Which I think about a good example to put that in later on. But we're going to use filter and a few things there in a more complete example later on. So just trying to show you the kind of different aspects of things in here. But yes, there's what do we got? So that's a reason why why you would use regexes and why you wouldn't use specific functions to kind of manipulate the subs. So subs has got limitation. Regex is much more flexible. Let's look at some other examples. If you wanted to pull out just the first character, we can use these \w to represent the first character in there, and we can specifically say, do we want 3 characters in there? Cool. Yeah. Yeah. So the \w is just going to match on one character, and then if we do refine, if we do 3 in a row, then we'll actually just get the 3 characters in there. So it's quite nice to be able to just dissect a piece of string from there. And even if there is cruft, there is like extra data before the words, these are digits, so it's not going to match on those. So we still get the same result as previously. So we can deal with messy data, dirty data very easily. And if we did want specifically the digits, we can do the same thing. So a number in regular expression is referred to as digit, so we can just pull it out with /d and get that value, and the same thing for those as well. There's a lot of flexibility. There's quite a few of these little things to learn, to pick up, and I'll dig out a nice kind of cheat sheet for those kind of things. But it's quite flexible in what you can actually do and how you can attack and dissect and transmogrify your string data very, very easily just by pulling out the bits of things that you actually want. And you can apply, you don't just have to apply a single pattern, you can apply multiple patterns. So here we're doing an OR statement really in here. So this is the same as a pattern that says, I want to find cat or kitten in whatever string that we've got here. So if we do that, it finds cat because we've got cats. We've also got putty cat as well, so it would match that as well. If we did reseek, then it would give multiple results. Refind is just giving us the first one. The same for kitten. My kitten has grown up into big cat, so kitten is first, so it's only going to return kitten. It will match on cat, but it's already matched on kitten, so it just terminates before it returns cat. And just to show the corollary of that, so if cat's first, then yeah, and kitten is also matched, but it's not displayed because we end the find before we once we get to something, the first thing that matches. So if we want multiple results from that, then we can do reseek. So we're creating a new sequence from this, and we get cat. We get cat here, and then cat from Pussycat as well. And the same thing here as well. We get both kitten and cats, and cat and kitten. So reseek is probably quite it's quite commonly used with regular expressions, because you want to, especially when you're working with strings and transforming strings, you want to pull out like a whole new sequence of just the particular parts that you want. So here we've got an example of a validation form. So let's see, I've written some functions here to check for multiple login names. So this is kind of assuming that there's in this case, there's a very finite number of users in here, and we're just using refind to see if there is a particular user. When we pass in the username, is it one of the established users that we have here? So this is all a bit hard-coded, but just shows you another example of how we can test for the results of a regular expression. So if we want a valid user, we just want to know whether something in whatever's in the username is that one of these particular users. So we're just using refind. It doesn't matter if there's more than one. And we can use the results of the refind as a Boolean test, as a condition for our if. So when we so regardless of whether it turns Jenny or nil, or if it returns any of the names, then that's going to be true. If it returns nil, then that's going to return false. So this is a more robust test than just counting things. So if we evaluate that, just to make sure it's there, yes, it's evaluated. So if we evaluate the user Jenny, that's true, that's in there. And if we do the same thing for Brian, I'm afraid you're not allowed in, your name's not down, you're not coming in. So again, it's a very simple validate users. If you've only got like 3 users, then you might not need a database there if you're never ever going to have more than 3 users. But if there are similar names, you might want to kind of match on anything else. So if you've got a whole bunch of account names, and you've got Jenny, Jenny 1, Jenny 2, Jenny 3, Jenny 4, Jenny 5, and so on and so on, and you want to match on any of them, then you can use the plus sign to kind of match anything essentially. So let's just evaluate that just to make sure it's there. There we go. So if we evaluate, that's not matching the pattern itself, so that's going to be false. But any of the other ones have the pattern and maybe something else. This one is just the pattern. This is a pattern plus an extra n, and that's still matching. And that's a full word. And this one is the full name. So all these will be matched using those gen plus. And so this saves you kind of just defining a lot of different, very similar names as you would do here. So you would have to add a lot of stuff here if you wanted to match all the Jens and Jennies and so on. And this is quite useful if you've got, if you look at Google, and if you're doing if you go to Google and search for Clojure, it's already kind of matching on a whole bunch of things that are more than Clojure, CLOJ, and it's given me a whole bunch of options. So this is another example of where you could use regular expressions to give you a list of things that actually match pretty close. to the pattern plus something else, essentially. So that's an interesting usage of regexes. I'm not sure if Google do that, but that's one way to do that. That's one way to implement that. What if you had all the characters of the alphabet? How would you match all those? Well, you really wouldn't want to do to type all that out in individual, like in a literal form. So you can use the A to Z range here instead. So this A to Z is the same as explicitly doing A, B, C, D, D all the way through to Z. So this syntax is just basically adding these a vector around it. So the square brackets are a vector in Clojure, and it's basically defining a character set. And you can define a range, and the start of the range, and the dash between them is just the start and end of the range as well. So it's pretty simple syntax. So we can match any word we wanted to. Here we've got a simple function. If our pattern matches the word, then we'll return true. And even if we make up weird words, it's still going to return true as well. What happens if we do a match word? Matching a word, and our word is oops. Boom. False. That's A to Z and A to Z. So why doesn't it work? Well, it's because these are both lowercase characters, and we've done our string in uppercase. And we could also kind of be, did I do? I think I did an example there. No, I didn't do an example there. There we go. Yeah, so let's look at that. So if I want to do match any word and any case, I would have to modify the character set I'm using. So if we wanted to match hello world, we could just put A and capital Z in there, but then it wouldn't match the other words. It wouldn't match these words because these are kind of lowercase as well. So we can do a mixture of both. So we can do A and Z. And this would match both lowercase and uppercase words there as well. Let's see words. Any case. There we go. And we can just do a partial kind of set of the alphabet as well. So just anything that matches A and C. So anything that's got the values of A and C in it. So this has got A in it several times, B as well. Cat's got A and C in it, so that's going to be true. And dog is going to be false because it's got no characters of A, B, or C anywhere inside it. And just playing around with other things here. So we looked at the multiple one. So here aardvark is going to match. If we do a sequence, it's quite interesting because we get the matches. So you can see how it's kind of working, applying the pattern to the first to the word, and it's getting AA, and then we move on to the second position, and it's also matching. And then it's also matching the aardvark here as well. So we can see how it's kind of matching several parts of the word with this pattern, and just returning the parts that match there as well. Yeah. You can do anything else? Oh, and yeah, I did do some examples here of using uppercase and lowercase as well, and also adding the multiply as well. Yeah, so here we're returning all the things that are uppercase and lowercase, and doing that multiple times, and everything else. Yeah, we've covered matching spaces. Oh yeah, and this is another example I found on the internet. So here we're also using the rematches. So we're using rematches with another function here, which is pulling back anything that kind of does match. So the whole thing matches because it's a word plus space plus word. So you've got basically any number of characters that are followed by a single space, that are followed by a single any number of characters. Again, is going to give the results. And we can use that in a let binding as well to kind of, again, break up. Another example of breaking up a string into pieces by using a regular expression. It's quite a complex one for the text we've got. A split would probably just work as well. It'd be a lot simpler. Oh, there it is. Yeah. But yeah, you can use rematches anywhere. You can do the function. It's just a normal function, just like refind and reseek. And we also saw like A to Z. We can do 0 to 9 for matching the digits as well. So that's kind of if you kind of understood most of that, then you should be able to start applying regular expressions to the things you're doing. And so refind and reseek are the most commonly used ones as well. Thanks for the shout out. Command log is quite useful. I will have a little kind of a little thing at the top that shows you the key presses I'm making as I'm going along as well, just if you are using Spacemacs. And there's a question: what's the difference between W space and W? Yes. Oh, okay. Right. So it's in groups. So the round brackets is kind of defining a group. So let's just see what happens. There. Actually, could do that. Could do that without these. I'm just going to unwrap those. Wrap those. Ooh. A bit of structural editing for you. I just basically unwrapped and took the round brackets, the lists from around that. And so it's just matching the overall expression, the overall string. So without the what the round brackets are doing is adding the groups in there. So it's showing the individual components of the results of the expression. So if we evaluate that again, oops, I'll do it again. So you can see here with rematches without the brackets around the word definition, it's just returning the results of the overall match. So anything that matches this overall pattern. Where with rematches here, it's if we put the round brackets around the W, it's going to return the group of that as well as a result. So this first one here, this specifically is returning Jenny, and this one is returning Jetpack as a group as well. So it's a way to kind of break down the overall string matches, but also the individual components, individual parts of the string are also matching as well. I hope that answers your question. Okay, and just to wrap this up, there's another example I have. I'm just going to close my I'm going to jump to my many layers. Where is it now? So here we have an example of using a regular expression a couple of times, actually. We've got a few ones, and hopefully we can kind of understand what they're doing now. So let's walk through this. So I've got a book here, which is the Hitchhiker's Guide to the Galaxy. I have many beautiful versions of this book, so I'm kind of just using the rough text of this I found on the internet. So if I evaluate this, then it's going to read in all the text of the book.